Page 315, question number 1. For part A, we're asked for the mechanical energy relative to the floor. So what we're shown is we have a pendulum with a length of 2 meters, and the bob, the sphere at the end, has a mass of 0.250 kilograms. When we pull this out to the side, the maximum change in height is 0.250 meters. As that swings down, the mechanical energy converts from gravitational potential energy into a combination of gravitational and kinetic energy at the bottom. But the key thing is, as it swings down, it doesn't gain or lose any mechanical energy. So if we can find the mechanical energy at any point in the motion, then we know what the mechanical energy of the system is. So at this point, the mechanical energy at the top is equal to the mechanical energy at every other point in the swing. So when we're looking at the top here, all the mechanical energy is gravitational potential energy. So to calculate our gravitational potential energy, it's mgh. It's stationary, so there's no other types of mechanical energy involved. So it's simply our mass, 0.250 kilograms, times g, 9.81 meters per second squared, times the height, 0.250 meters at the maximum height, and that will give us our mechanical energy. So on the calculator, 0.25 times 9.81 times height of 0.25 gives us a value of 0.613125, so it rounds off to 0.613 joules of mechanical energy in that pendulum system, no matter where it is in the swing. Part B, what is the kinetic energy? Now, for this point, we're going to use the fact that our mechanical energy at the top is equal to the mechanical energy at any other point in the swing. Now we've already figured out from part A that our mechanical energy is 0.613 joules. So that is our starting value for mechanical energy, and we know our mechanical energy is made of kinetic energy as it swings down and gravitational potential energy. So when it's part way between the highest point and the bottom, it's going to have some kinetic energy and it's going to have some gravitational energy that make up that mechanical energy. So substituting in our equation, EM minus EG will give us our kinetic energy that we are looking for. So to find that kinetic energy, it's going to be our mechanical energy minus mgh. So our mechanical energy is 0.613 joules. Again, our gravitational potential energy will be the mass, 0.25 kilograms times g, 9.81, and our height, in this case we're 0.15 meters above the ground. That will give us our kinetic energy. So EK is equal to 0.613 minus 0.25 times 9.81 times our height, 0.15 meters, gives us a value of 0.245, and it doesn't round up, joules of kinetic energy. Using that, part C is asking us to find its speed. So we know that the kinetic energy is equal to mv squared divided by 2. Rearranging this for v, we get v is equal to the square root 2 times the energy divided by the mass. So to solve that, we're going to have 2 times our energy, 0.245 joules, divided by the mass of our object, 0.250 kilograms, and we need to square root that whole thing. So on our calculator, we get the square root of 2 times 0.245 joules this time, divided by 0.25 kilograms, gives me a value of 1.4, so it's going to be 1.40 meters per second as the velocity at that point. And again, we don't know if it's swinging down or up. Our calculations for energy are scalar, so it does not give us direction.